Okay, now so far dealing with the derivatives of trigonometric functions, we've already gone through functions like sine of fx, but what if we have a sine or cos function or any trigonometric function raised to the power of a constant? How do we differentiate that? And that's what I'll go through in this video. So to start with, let's take something straightforward. Let's say we have sine squared of x. We want to differentiate y equals sine squared x. And when we write sine squared x with trigonometric functions, squares and cubes are written like this. It is the same as sine x to the power 2. These two are identical, but with trig functions, it's almost always written in this form. But it's no different to saying sine x and all of that to the power 2. It's probably just to distinguish it from sine x squared. So this is different from this, but if you put brackets around it, then these two are identical. Okay, now differentiating this is no different to differentiating functions of the type fx to the power n. And in this case, fx just happens to be a trigonometric function. Okay, so let's see how we can differentiate this. And as always, I'll go through a t substitution. I'll show you the longer method, and then I'll also go through the quick way of doing it. Okay, now to use a t substitution, I'm going to use t equals sine x. So let's say let t equals sine x, in which case y would be equal to t squared. Because if sine x is equal to t, then I can replace sine x with t, and that is equal to y. Then I get dt over dx, differentiating sine x, I would get cos x, and then dy over dt will be equal to 2t. That's the derivative of t squared. And then using the chain rule, I can rewrite this as dy over dx is equal to dy over dt times dt over dx. And this is just the chain rule again. And dy over dt is equal to 2 times t, and dt over dx is equal to cos of x. So I get 2 times t times the cos of x, and t is equal to sine x. That is the initial substitution I used. So I can replace t with sine x to get 2 sine x times cos of x. And if you know your trigonometric identities, then you'd also know that this is the same as saying sine of 2x. And if you don't know how I get this, then don't worry about it. As far as differentiating it is concerned, it's done at that point. Okay, I'll take one more example before going on to showing what the quicker method is. And let's say y equals tan cubed of x. Let's say we have y equals tan cube x. And this again is just simply means that y is equal to tan of x, and that cube, I could rewrite it in this form. And this time my t substitution is going to be the tan function. So I'll say let t equals tan of x. And if t equals tan of x, then y must be equal to t cubed. Then I take dt over dx. Now dt over dx, the derivative of tan x is sec squared x. So that gives sec squared of x. And dy over dt would be equal to 3t squared. And then using the chain rule, I can say that dy over dx is equal to dy over dt. So I'll write it like this. I have dy over dt times dt over dx. And substituting for dy over dt and dt over dx, I get dy over dt, that's 3t squared. Then I've got times dt over dx, which is equal to sec squared of x. And then substituting back for t, I get 3 times tan squared x, or tan x squared, whichever way I want to write it. So that's tan squared x sec squared x. And this would be the derivative of tan cube of x. And if you watch the video on differentiating functions of the type fx to the power n, I showed that the derivative of this type of function, so if I differentiate this function with respect to x, what I get is something like n times the function with the power reduced by 1. So that's n times fx to the power n minus 1 times by the derivative of fx. And if you check, that's what's happened here as well. And at the beginning of this video, I just said this is the same as this, and the only difference this time is that the fx just happens to be a trigonometric function. And if you think about fx being equal to tan cube of x, or fx being equal to tan x, and n being equal to 3, so what I've done is I've taken the power down, so that's 3 times, that's my n, tan x squared, so the power has been reduced by 1, and then I multiplied that by the derivative of tan x. And if I just to take another example, let's say we have y equals sine x to the power 5, or sine to the power 5 of x, then dy over dx will be equal to, I bring the power to the front so that I have 5 times sine x, but now the power is reduced to 4, and then I've got to multiply that by the derivative of the sine function. So the derivative of sine is equal to cos of x. Okay, let's now take another example with, let's say, a cos function. Let's say we have y equals cos 3x to the power 6, and I want to do dy over dx. So I have some function raised to the power of a constant, so the derivative will be equal to, I'm going to get 6 times the cos of 3x, so bring the power to the front, leave that function as it is, reduce the power by 1 so that I get 6 cos 3x to the power 5, and then I'm going to multiply that by the derivative of cos 3x. Now the derivative of cos is minus sine, so I'm going to get minus sine of 3x, not just 1x, so I'm going to get minus sine 3x, and from the previous videos you've seen when it has cos of some function, I've got to multiply by the derivative of that part as well. So I'm going to get minus sine 3x times 3. So this becomes, I can multiply this 3 and 6 times the minus sign. So that gives minus 18, that's right, cos to the power 5 of 3x times the sine of 3x. And once again, if you want to do a detailed working, just to choose cos 3x to be equal to t, choose t equals cos 3x, and then you can do the t substitution and substitute into the chain rule. And I think we'll do one with the cot function as well. Let's say we have y equals cot x, let's say cot of 3x to the power, let's say 4. Okay, so what's dy over dx in this case? So dy over dx, bring the power to the front, so I get 4 times cot of 3x to the power 3, reduce the power by 1, and then multiply that by the derivative of cot 3x. Now the derivative of cot is minus cos x squared x, but I'm going to get minus cos x squared times 3x, and then I'm going to multiply by the derivative of the 3x as well. So I'm going to get times 3. So the derivative in this case is going to be 4 times 3 times the minus sign. That's minus 12 cot cubed 3x times cos x squared 3x.